Hi guys, today let us solve some numericals based on the concept of circular motion. Well, a flywheel rotates at 200 rpm. A uniform retardation is given for 10 seconds and rotation reduces to 160 rpm. Determine first the time taken by the flywheel before it comes to rest from the 200 rpm and next the number of revolutions made by the flywheel before it comes to rest. Now, they've given us that the flywheel will be initially at 200 rpm and hence n0 will be 200 rpms. Hence, now the angular velocity omega naught will be given by 2 pi n0 by 60, that is nothing but 2 pi into 200 divided by 60, and hence omega naught will be 20.94 radians per second. Similarly, the final rotation speed is given to be, that is n 160 rpm. Hence, the final angular velocity omega will be 2 pi n by 60, that is nothing but 2 pi into 160 by 60, which will be 16.76 radians per second. Now, they have given us that the flywheel will undergo a uniform retardation, that is nothing but negative acceleration, for 10 seconds. Hence, t will be 10 seconds, and applying the equations of motion in circular motion, we have omega equals omega naught plus alpha t. Hence, we have 16.76 to be equal to 20.94 plus alpha into the time t, that is 10. Hence, from this, we get alpha to be minus 0.418 radians per second square. The negative sign indicates that it is retardation as given in the question. Now, from the equation of motion, we know that omega square minus omega naught square is equal to 2 alpha theta, where theta is the angular displacement before the flywheel comes to rest. Here, the initial velocity will be same, that is, the initial angular velocity will be 20.94. The final angular velocity will be 0 here, as it is given that the flywheel will come to a rest. Hence, substituting these values, we have omega square minus omega naught square to be equal to 2 alpha theta, that is 0 minus 20.94 to be equal to 2 into minus 0.418, that is the angular acceleration, into theta. Hence, from this we get the value of the angular displacement theta to be 524.5 radians. We know that theta is given by 2 pi n. Hence, now the number of revolutions n can be given by theta divided by 2 pi, which is nothing but 524.5 divided by 2 pi, which will give us the value to be 83.48 revolutions. Hence, the flywheel will take 83.48 revolutions from 200 rpm to come into rest. Now, the time taken for it to come to rest is given by omega equals omega naught plus alpha t. Hence, substituting the values, we have 0 is equal to 20.94 minus 0.418 into t. Hence, we get the value of t to be 50 seconds. Hence, the flywheel will take 50 seconds to come to rest from 200 rpms. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.